So how do horizontal pressure gradients look like? In order to understand horizontal pressure gradients, you have to remember that pressure relates to the weight of the water column above a reference point. Okay, pressure itself is proportional to the weight of water above you. So there are two processes or two features that create horizontal pressure gradients. One is you have a sloping sea level or sea surface. Okay, so you have more water on one side at a certain reference depth compared to a different location at the same horizontal at the same depth. Okay, you can see that. And this situation initiates a horizontal pressure gradient, which then becomes controlled by the Coriolis force. Okay, so similarly, or in addition to that, you also have a density stratification in the ocean interior. You can also get additional effects if you have a sloping pycnocline, a density surface that's sloping relative to the horizontal. Okay, and horizontal is always defined as the one that is perpendicular to the gravitational force. Okay, we talked about that before. What's vertical? What's the horizontal? Anyway. Okay, so in this situation here that I show in this graph is the sloping sea surface sets up a horizontal pressure gradient force on the surface layers, and then because the pycnocline is sloping in the opposite direction, you actually get a reduction of the pressure gradient force with depth. These are horizontal forces, but it becomes smaller. We call it two-layer ocean. We just assume we have two fluids. And this feature is already linked to a process we call baroclinic compensation. This is a typical feature that we find in the ocean. Pressure gradients tend to decrease with depth, and the geostrophic flows that you get actually tend to disappear in the open ocean at depth below 1 to 2 kilometers. Okay, so now just a link to one of the preps that you're going to do. So either face-to-face or online, is the situation shown here just over my shoulder. You have a situation, you have a tank, and you have dense water, say very salty water, next to light water. Okay, you look from the side. And then indeed, if you think about it, how do you get a pressure gradient? The relative weight difference increases as you move down to the bottom here. So you get the strongest horizontal pressure gradient force near the bottom. And then you already can guess what will happen. So the dense layer will spread along the floor only in a non-rotational fluid. Okay, with the Coriolis force it looks all different. But anyway, so this is again a situation that produces a horizontal pressure gradient. It creates a current that over time becomes influenced by the Coriolis force. Okay, let's have a look how the Coriolis how the geostrophic balance looks like.